Nanobead technology is the kind of technology now that I invented a while back. I actually started back in June 2012. Um, so I'm going to read to you an abstract that I wrote about this particular method of nanobead production called lithography method. Um, the basic this describes the basic concept and everything, and so I wrote this on Friday, August 17th, 2012. The following is a concise description of a conceptual technology called nanobead technology. It was originally conceived by John Jack Lawrence Cullinane IV on June 2012. The concept is theoretically proven from function to product manufacturing due to the research of a variety of scientists and engineers, all cited below. That is research that I've garnered on the internet from scholarly papers and journals and that kind of thing. I'll cite all of them and describe all of them as I go. So, the basic descriptive concept of nanobeads is akin to your atypical Mardi Gras necklace. As you might imagine, these necklaces consist of a series of spherical, smooth plastic beads separated along a string. Although nanobeads are inevitably derived from different materials and are constructed on a much smaller scale with drastically different purpose, the basic structure is the same. Before I go into further description, allow me to illustrate. If you're not really sure what I mean by a Mardi Gras necklace, I don't have one with me, but I have this. It is the basic kind of necklace you might find like on a pair of dog tags, something like that. Well, you notice the structure. Spheres connected together. This is the basic structure of nano beads. Each bead is one of the spheres, of course, and this and then you have the nanowire in between them. I'll get to further description. It is necessary to first explain the nature of this technology. The name nanobead comes from the fact that it's a kind of nanotechnology. Nanotechnology is defined by the National Nanotech Initiative, a government initiative, as science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. The beads in nanobead technology, in other words, the spheres, measure about 100 nanometers in diameter. The so-called string is, in fact, a nanowire measuring about 20 nanometers in diameter. The beads consist of an 80 nanometer iron core and a 20 nanometer copper film that is placed that is 20 nanometers thick, that is placed by using nanotransfer printing, as described by Blue. In a paper he and several other scientists wrote way back when, let me see, it was Yulin Lin, Robert Willett, Kirk Baldwin, John Rogers, and it was made, it was called additive nanoscale patterning of metal films with a stamp and a surface chemistry meditated transfer process, applications in plastic electronics, in the applied physics letters, volume 81.3, published on the 15th of July 2002, that source from the American Institute of Physics. And I got that online on June 15th, 2012. So, to continue. The effect produced by this iron core and copper film is that when an electric charge is applied, it creates an electromagnet, as any basic electromagnet is described. You put a copper wire around an iron rod, that's what you're going to do. It's the same thing on the nanoscale, theoretically. This is where the power of this technology is created. By the systematic serial management of these nanoscopic electromagnetic spheres, one can produce a multitude of effects in fields that range from energy production to computational devices and processing. I will get to that later. And even materials engineering, as well as much more. What I mean by energy production is a theoretical way of producing a spring effect with the nanobeads, such that it actually produces a turbine kind of thing. vibration-sensitive turbine. This is not a proven technology. I've not gone through deep designs into this, but it is an intention of mine to do so with Cullinane Technologies. For materials engineering, I have a theory that if you put nanobead structures into a general plastic mold, it will actually strengthen it, such as through like rebar. Once again, something that's not proven, something I have to do in physical R&D, but I'll get there later. And these various effects and products achieve various purposes in products. So the basic copper structure of the beads can be functionally manipulated using to achieve various purposes in products. The basic copper structure of the beads can be functionally manipulated using nanotransfer printing, same thing as before. Through the use of these processes to create a wide range of products, the technological landscape of the most important fields of technology today can be greatly advanced with relatively little cost in either manufacturing or consumer price. The reason for that, I'll get in below later, is that these technologies can produce using recycled materials. All the materials that I'm talking about here are easily accessible. In fact, even nanotransfer printing doesn't take chemicals that are too complicated. So that is advantageous. That makes production costs lower, and I will be producing a lot of the later devices using additive manufacturing, such as with like 3D printing. So there'll be a lot of ability to do that. Now, I haven't gotten into designing the manufacturing process for the other computer technologies that I listed below later. So we'll get there. The manufacturing process for nanobead products is relatively simple to conceive. Imagine a kind of sculpting process. However, considering we're dealing on a molecular level with nanotechnology, there comes some complications. To achieve this technology, the manufacturing process is where some research and development might be necessary. Such research would most easily be conducted through a trial and error process. The reason for that is simply because with nanotechnology, you can't really gauge what's going to happen, so you have to be able to adapt. So outside, the materials needed for manufacturing are simple. Outside of specialized equipment, all that is necessary is silicone plates such as wafers used in circuit building. Then all that is necessary is chemical and a pressurized chamber for microcontact printing and nanotransfer printing. Microcontact printing is a previous method that I use. It does basically the same thing as before. It was produced in a paper. I believe I should have that still. Yeah. Let's see, where is it? Yes. It was produced by Serge Hallen, Primin Hidberg, Jean-Philippe Bergeon, Corinne Miramond, and Claude Fermin. Oh, and George Whitesides, in a paper patterning with magnetic materials on the micron scale. It was published in Chemistry Materials, volume 8.6 in 1996, found in the American Chemical Society. So, that's microcontact printing. It's basically the same process as nanotransfer printing, just on a slightly different scale. So, it's not something that I really intend to use too much, but yeah. So with those processes, they required for the production of copper film and the programming of nanobeads, as I said before. Now, all of these materials, perhaps except the solution chemicals, but including those materials used in some possible nanobead programming schemes, can be required using established recycling techniques, thereby reducing costs. The basic concept of manufacturing most any nanobead product are as follows. First, the 80 nanometer thick film of an 80 nanometer thick film of ferromagnetic iron is chemically produced over a silicone wafer using microcontact printing. Using a high-resolution method of top-down optical lithography with a laser of around 650 nanometers in wavelength, systematically will etch the top section of a nanobead cores along the nanowires. That process is cited from an article in EE Times Europe called Laser-Based Optical Lithography to Yield the Resolution of 2 nanometer half-pitch lines. It is written by Julian Happich in January 4th, 2012. The partially Next step in the process is partially lithographed film is then flipped and transferred onto another wafer, and the other side of the etching is completed. The finished grid of nanobead cores and wires is then transferred to another place and undergoes nanotransfer printing to coat the beads with 20 nanometer thick coating of copper that is used in glue. After that, the copper coating is set, the nanobead grid is placed in other molds that can facilitate the creation of other films and impressions using nanotransfer printing depending on the desired programming for that batch of nanobeads. Once the nanobead grid is complete, the grid can then be placed in whatever product housing that can be designed for it as per the needs of the product. Once the grid of the nanobeads is in place, the specialized electrical pulse silicone grid is molded to the negative of the nanobead grid and is placed over the completed nanobead grid, and electrical charge runs through the silicone plate to the nanobead, thereby electrifying the electromagnetic nanobead grid simultaneously. I don't have necessarily drawings of that, but you can imagine the grid. Okay, you have these nanobeads, right? And the basic idea is that there's a grid that these nanobeads place into, and that grid will simultaneously electrify all of them at once. So that exists. It is similar to a design for the nanoprocessor that I'll be showing next. It's similar to that grid. You'll see. Don't worry. So in some ways, this process is still theoretical. However, for the most part, it is conceivable. Due to the ease with which the process occurs, as well as due to the scale, most, if not all, of the process will and can be automated. After the silicone molds are used, they can then be recycled back into the system. Also, all excess solutions can be collected, cleaned, and reused. Using these kinds of techniques, not only can the process be streamlined, but the cost of manufacturing is greatly lowered, especially considering the relatively very small amount of material used to create each batch of nanobeads, seeing as it is a nanotechnology. There'll be less material used than other, say, processors. One thing I'm imagining that he'll get into that later. Given the ability to research and develop this technology, and assuming all theoretical and assumed knowledge is determined true, this technology is not only viable but extremely valuable. Thus, I would ask discretion in any and all future discussion and the use of previous information. So that is the basics of nanobead technology. Now, this is technology that I have established elsewhere. I submitted to the Siemens competition done by Siemens Foundation. It's a high school science and technology and mathematics competition where you submit a full report. I submitted one. I have a confirmation letter. I'm not going to show that to you. I don't need to. But that competition, I didn't make it in that competition, but it is submitted in that competition. All the materials, a much more detailed description of the technology is in that, and detail of the methods and exactly everything I had, all the research. So all of that is described much more thoroughly in that packet, which is with Siemens Foundation.